Hello grade 10s and welcome back to my YouTube channel. Today we're going to go over some maths paper 2, and in particular we're going to focus on analytical geometry, grade 10 exam questions. So as you can see, we're going to be going through national senior certificate papers, grade 10. Let's jump right in. If you haven't subscribed to my channel, please do so now. I do maths videos, I do science videos, and all things like that to help you get better marks. Let's jump right into the exam questions. So first of all, when you get a question like this in your exam, it's very, very important to always make sure you read the information given before any diagram. I know they give a diagram and I know they indicate things on the diagram, but it is very important to make sure that you read that information and fill in any additional information that has not been indicated on the diagram yet. So it says in the diagram below, they give me point P, point Q, and point R are the vertices of a triangle. Okay, you can clearly see we have a triangle such that PQ is equal to QR. So that's the first part of information that they give me that isn't necessarily indicated on the diagram. PQ is equal to PR. We're just going to have to keep that in mind for later on. And PQ is perpendicular to QR. We know that that means that it forms a 90-degree angle, which they do indicate on the diagram. T is a point on PQ, okay, so it's on the line, it's on that same straight line, such that T is the midpoint. I'm just going to write MP here for midpoint, so I remember, of PQ. S is the point of intersection of RQ and the x-axis. Okay, so S falls on the line QR or RQ, and it's the point of intersection or the x-intercept of that line. Okay, and V is a point on the x-axis such that QSV, angle QSV, is 121. They give me that over there. And then they say QPS is theta, which they also indicate on the diagram. It is very important to draw in any additional bits of information or revisit this paragraph as you go through the questions. So these are the questions that we will be looking at for this one in particular, and we're going to go through each of them one by one, and I'm going to show you how we get to the answers. So the first few questions will always be more straightforward than the ones to follow. So you can see they ask for length of PQ, they ask for gradient, they ask for coordinates of T, and remember T was the midpoint. So these are all the more basic types of questions, and then later on you can see they ask things like calculate angles, calculate area, things where you have to think a little bit. So my first question wants the length of PQ. That is this line over here. So to get the length of PQ, we're going to use the length or the distance formula. We have both coordinates. So there's my formula. There's my two coordinates. I've just rewritten them and I've wrote x1, y1 on top of my first coordinate, which I chose to be P, and then x2 and y2 on top of my second coordinate, which I chose to be Q. It doesn't matter which one is your number 1 and which one is your number 2. I just chose it arbitrarily, and then we're going to sub into our formula. Just make sure to sub in very, very carefully. So x2 would be over here 6 minus x1, which is 1. We square that. Y2 is 3 minus y1, which is 0. We square that. We're basically going to get the square root of 34 if you do that. It says leave your answer in surd form, so we're going to leave our answer in surd form. There we go. Next question. Our next question wants us to get the gradient of PQ, so the same line, but now we want the gradients, so we need to use the gradient formula. We know the gradient of PQ. Gradient is always going to be y2 minus y1 over x2 minus x1, and I'm going to rewrite P and Q as I had it for the previous question. Same coordinate will be my number 1, same coordinate will be my number 2, and I'm going to sub it in. Right, so y2 is 3 minus y1, which is 0. x2 is 6 minus x1, which is 1. So it is 3 over 5. Our next question wants the coordinates of T. Now remember T, they mentioned in the question. So if we reread the question carefully, it says T is a point on PQ such that T is the midpoint of PQ. See why it is super, super important to read your question, because now we know that T is the midpoint and we can use our midpoint formula to get the coordinates of T. Right, so here's my midpoint formula. I'm looking for the coordinates of t. As we know, coordinates have x and they have a y. So this is how I find the x and this is how I find the y. Remember, it's the midpoint. We're going to use p and q. x1 plus x2, 1 plus 6, we divided by 2. y1 plus y2, 0 plus 3. Remember, xy and xy divide by 2, so t is going to be 7 over 2 and 3 over 2. There we go. That's my coordinates of t, my midpoint, 7 over 2 and 3 over 2. For question 2.2, they want the area of triangle QTR. Now, first of all, make sure you know what triangle they're talking about. So I'm going to highlight it for you. QTR, that's the right angle triangle over there. So remember, area of a triangle. Let's remember the formula, the area formula. Area of a triangle is half times the base times the perpendicular height. Now, it's perfect because we know that QT is perpendicular to QR. They mentioned that in the question. They give me the 90-degree angle. So that means that QR would function as my perpendicular height. Or if QR is my base, QT would function as my perpendicular height. So basically what I need is to find the area is I need the length of QT. That's the one length I need. And I need the length of QR. And again, the reason why is because area is half times base times height. So let's pretend that QT, this over here, QT, is my base. So half times QT, the length of QT, times the perpendicular height. If QT is my base, then this length over here, QR, is my perpendicular height. So I need to find QR and QT. So first thing that we're going to do is we're going to revisit the paragraph that they wrote over here about this question. So if we look at the paragraph, they say this very important piece of information over here, which I did mention earlier. PQ is equal to QR. Okay, QR. And remember, we said QR is one of the heights that we need. So PQ, remember we found the length of PQ in the first question. PQ was the square root of 34. And we know that PQ is equal to QR. So that means QR is also the square root of 34. So there we go. That's my first important piece of information. So there we go. QR is equal to PQ, which is equal to 34. And that information was given to us in the question. And then QT. Now, if you take a look at the diagram, we can see that QT, so I'm just erasing this, everything that I've written over here for you. You can see that QT, remember T was the midpoint. T was the midpoint of line PQ. And if we know PQ is the square root of 34, and if T is the midpoint of that line, then TQ or QT, so this piece over here must be half of the square root of 34. So half of the square root of 34. That should make sense because T is the midpoint. And from P to Q, so that whole line over there is square root of 34. Then Q to T, half of it must be half of the square root of 34. So there we go. We've got QT, which is my base. We've got QR, which is my perpendicular height. We can sub it into the formula and get the area. There we go. I've subbed into the area formula for you. Half times base. Now in this case, I've taken my base to be QT. And remember, this whole line over here, PQ, was the square root of 34. T is the midpoint. So this blue section is half times square root of 34. So I've highlighted it there in blue. So half times base times height. And the height was QR, which they told me was the same as PQ, which was square root of 34. When we multiply those together, we get an area of 17 over 2, which is 8,5 square units. They don't tell me the units, so we're going to say square units. Remember, when you're calculating area, you're going to get square units. In our next question, they want the size of theta, and as you can see, theta is over there. It is measured over here from the x-axis, over there, from the line here, from the x-axis to our line PQ. That is the angle over there. And the only other angle that they give us is 121 degrees, and we also know this 90 degrees over here. So we actually know two angles, 121 degrees, 90 degrees, and we're looking for theta over here. Now, there's more than one way to do this. If I work in this triangle, so I'm going to highlight the triangle that I'm talking about. If I work in triangle PQS, this triangle over here, triangle PQS, I can work with 121 as being the exterior angle of triangle PQS. So if you look at triangle PQS, it's the yellow triangle. 121 is the exterior angle of that triangle. And what do we know about exterior angles of the triangle? We know that the exterior angle of the triangle is equal to the sum of the two opposite interior angles. So 121, this angle over here, 121 degrees, which is the exterior angle, is equal to 90 degrees plus theta. 90 degrees plus theta, the two opposite interior angles. And from that, we can work out that theta is therefore 31 degrees. Remember, every time you give a statement, you have to give me a reason. So what I did over here is I used exterior angle of triangle PQS. That's what I used. There is another way to do this. So you can use angles on a straight line to find angle QSP, this angle over here, or PSQ, that angle over there. And once you have that angle over there, you can use sum of angles in a triangle to work out theta. So sum of angles in triangle PQS. Hope that makes sense. You'll get to the same answer. You'll just have two steps. Our next question wants the coordinates of S. Now remember from what we read above, this is why this paragraph is so important. Just to repeat, it says S is the point of intersection of RQ, so straight line RQ, here you can see RQ, and the x-axis. In other words, it's the x-intercept of RQ. Now, grade 10s, there are a lot of different ways that we can get coordinate S. I'm going to share a few with you, but you can do everything from using trigonometry, using the gradients of lines. We can find the equation of QR and look for the x-intercept. So I'm going to show you three methods actually. My first method is exactly that one that I just mentioned. If I find the equation of QR, remember QR is a straight line, so it will have an equation in the form of y equals mx plus c. Okay, it's a linear function, straight line. If I find the equation in the form y equals mx plus c, and I look for the x-intercept by subbing in 0 in the place of y. So remember, when you're looking for the x-intercept, you make y equal to 0. And if I can do that, I can find the x-intercept, which would be point S. So that is my first method that I'm going to do. Now, in order to find the equation y equals mx plus c, I need the gradient of the line QR. I need the gradient of the line QR. Once I have the gradient of the line QR, I can solve for my y-intercept by subbing in one of these points. Okay, so step 1, find the gradient of QR, which is m. There we go. I found my gradient of QR by using the gradient formula, y2 minus y1, x2 minus x1. So in this case, I used this as x2 and y2, x1 and y1. Now there is another way that we could have found the gradient of QR, perhaps a faster way. We know that this is a 90-degree angle, and that means that QR is perpendicular to line PQ. And what do you know about the gradients of perpendicular lines? That means the gradient of line PQ multiplied by the gradient of QR would be -1. And we know the gradient of PQ. We found it in, I think it was the second question. Let's just go and have a look. The gradient of PQ was 3/5. So if you know the gradient of PQ, which is 3/5, if we have to multiply that by the gradient of QR, which is the perpendicular line to PQ, see, they're cut at 90 degrees, or there we go, perpendicular, that gives me -1. If you solve for the gradient of QR, you get -5/3, which is exactly what we got when using the gradient formula. So either way, I've got the gradient. So I've got m. Awesome. Now my next step would be to find C, which is my y-intercept. To find C, my y-intercept, I'm going to take one of these 2 points that fall on the line QR. So I'm going to just choose Q. I'm going to sub that into my X and my Y, and I'm going to solve for C. So there we go, y equals mx plus c. I filled in my gradients, and now I chose Q. I'm going to sub in the x, and I'm going to sub in the y. So the y is 3, negative 5 over 3 is my gradient, multiplied by my x, which for this coordinate is 6, plus c. If I do that, c comes out as 13. So what I did is I first said negative 5 over 3 multiplied by 6, that got me negative 10. You take the negative 10 over, so it becomes 3 plus 10. You get c is 13. So therefore my equation is y equals negative 5 over 3x plus 13. And now that is the equation of this line over here, okay, line QR. That is the equation of my line QR. Now I know that S, which is what I'm looking for the coordinates of S. S is my x-intercept. And to find the x-intercept, you make y equal to 0. So in the place of y, I'm going to put a 0. Negative 5 over 3x plus 13. And then you solve for x. So take the 13 over, it becomes negative 13. And then to get x by itself, it's currently multiply by negative 5 over 3. We divide, therefore, by negative 5 over 3. And we get x is equal to 7, 8. And as we know, this is the x part of my coordinate s. S is a y-intercept. So, sorry, an x-intercept. So we've got x, y, 7, 8, and 0. That would be the coordinates of s. So y is 0 and x we just solved for is 7, 8. Another way to do this is once you find the gradient of QR, like we did previously, whether you use the gradient formula or whether you use the fact that PQ and QR are perpendicular lines and their gradients multiplied together gives me negative 1. So both methods that I used earlier to find the gradient. Once we know the gradient of QR, that gradient is negative 5 over 3. We know that the gradient for QS would be the same. Why? Because these points are collinear. They're all on the same straight line. They mention in the little story before they give the diagram that S is a point on QR such that it is the x-intercept of QR. It's where QR cuts or intercepts the x-axis. So we know that QS is on the same line as QR, which means that the gradient of QS will be the same as the gradient of QR, which is negative 5 over 3. Now, why do I care about that? Because I can use the gradient formula for QS to work out my coordinates of S. So how would I do that? Well, we know Q's coordinate is 6 and 3. We know S's coordinate is something, so unknown, and 0. How do I know that this is a 0? Because it's an x-intercept. So x-intercept, y is 0, but the x is unknown. Now, if we use the gradient formula, remember it's y2 minus y1 over x2 minus x1. Let's call this number 2 and let's call this number 1. It doesn't really matter. So y2 will be 3 minus y1, which is 0, over x2 would be 6 minus x1, which is x. And that gradient we said over here was negative 5 over 3. If you solve for x, and I hope you know how to do that, my unknown is at the bottom of the fraction. It's in the denominator. So I hope you guys know when solving. This is just something to make it easier. If your unknown or your variable or whatever you're solving for is in the denominator of the fraction, then the denominator of the fraction can swap places with this over here. So we've basically got 6 minus x and then 3 divided by negative 5 over 3. Okay, so 3 divided by negative 5 over 3 is equal to negative 9 over 5. So I've got 6 minus x equals negative 9 over 5. And then if you solve over here, so if I take this over, we're going to have negative x. I'm going to have negative 9 over 5 minus 6. I'm going to get negative 7 comma 8. Divide both sides by negative 1. So I'm going to get x is equal to 7 comma 8. So therefore the coordinates of s once again would be 7 comma 8 and 0. Okay, I don't know how many people would enjoy using this method, especially because when it comes to the solving part, people often make mistakes when it comes to solving for x. People get confused, they don't know what to do, they don't know how to isolate the variable, but that's basically it. So, I mean, just to make this easier, negative 5 over 3 is, okay, written as a decimal, it's a horrible number, but it can basically swap places with the 6 minus x. Another way to think of it is this: if you prefer to cross multiply, but remember you can only cross multiply like this when you have an equal sign. So 6 minus x. If this makes you happier, you can go 3 times 3 is 9, and then you can cross multiply this way. Negative 5 times 6 minus x, and that gets us negative 5 times 6 is negative 30, and this will get us positive 5x equals 9. So then we got the negative 30, take it over, it becomes plus 30, or add 30 to both sides. So 9 plus 30 is 39. So you're going to get 39 is equal to 5x. And then you say 39 divided by 5, and you get exactly the same answer. You get x is equal to 7 comma 8. Just please be careful when solving. Please, please, please be careful when solving, because you can lose marks by doing incorrect basic solving. Another really cool way that we can find the coordinates of s is actually to use trig. Because I have this angle over here, this theta over here, what I can do is I can work out the length of PS using trig, using this angle over here, and using the fact that I know the length of my, because remember, look at where your 90 degree is. It's over there. So PS is actually the hypotenuse of that triangle. I don't know if you guys can see that. Angle Q is 90. So therefore the angle, or the side opposite the 90 degree angle, is the hypotenuse. So PS is actually our hypotenuse. And we know that PQ over here is the square root of 34. And because we have this angle, 31, we can use cos. So we can say cos, remember cos of theta is equal to adjacent, the adjacent side over hypotenuse. So look at where theta is, where 31 is. Cos 31 is equal to the adjacent side, which is this side, PQ, which is square root of 34, over the hypotenuse, which is PS, which is what I'm looking for. And you might think, okay, if you get PS, the length of PS, how is that going to help you find S? I will show you in a second. Now remember, when your variable, when your unknown is in the denominator at the bottom of the fraction, this swaps places with this. So we've got PS is equal to the square root of 34 divided by cos 31. And if you do that on your calculator, you get the length of PS as being 6,80 units. Okay, so now we've got the length of PS. So let me show you how that actually helps us. We know that PS, so from here to here, is 6,8 units along our x-axis. But S is this coordinate over here, and we obviously need to include this little PC over here along our x-axis. And how do I know what that is? Well, over here we have coordinate P, and coordinate P is 1, 0. That means that this little bit over here is 1 unit, this little squiggle bit over here, and the yellow is 6,8. So therefore, from our y-axis over here to our S, okay, so that our S, our coordinate over here, we have 1 plus 6,8, therefore 7,80 units is my X part of my S coordinate. So therefore S is 7,8 and 0, okay, because it's over there. It's where the y is equal to 0. It's an x-intercept. So I hope that you can see that there are lots of different methods to get to the same answer. You do whatever comes to your mind, whatever makes you happiest, but it's good to know that there's more than one option. It just opens the possibilities. Maybe in an exam, you get stuck with doing it the one way, and then you can remember, oh wait, I remember that past exam question paper where Miss Martins used trig. Maybe I can do the same. Just remember that we have a 90-degree triangle here. That's why I could use cos theta. Just keep that in mind. Now 2.3 says determine with reasons the gradient of the line through T and the midpoint of PR. Now PR is over here, okay, PR. The midpoint of PR will be somewhere over there, and they say the line through T and the midpoint of PR. So basically, sorry for that not being straight, they want the gradient of this line. There's two ways to do this once again, or two ways that I will show you at least. And the first way I think is pretty cool. So see if you can follow along with what I'm saying. This line over here, we don't know what this point over here is called. They don't tell us to give it a name. They don't say, so whatever. We're just going to call this midpoint. I'm going to say midpoint of PR. Okay, that's what I'm going to call that point. So they say the line through T and the midpoint of PR. Now, what we know about that, a midpoint, is that we will know that that distance over there will be equal to that distance because it's a midpoint. If that's a midpoint of PR, then that will be half of the line and that will be half the line. That's what midpoint means. It means it's halfway through. And we know that T is the midpoint of PQ. That means that that is equal to that. Now, you do Euclidean geometry. You have done the midpoint theorem. Does this not look like the midpoint theorem to you? Remember, if we have a triangle like that, and I tell you that this is the midpoint of one line, this is the midpoint of another line, so we have the exact same information that I've drawn there. If that is given to us, so the midpoint of two lines, and then we connect those two midpoints with a line like that, what we can therefore say, given that information, is that this line over here, let me highlight it, this line over here is parallel to this line over here. Okay, so given the fact that this is the midpoint of this line, let's call this AB. We know the midpoint of AB, we know the midpoint of AC, this line over here. We can conclude, let's call this E, let's call this F. Okay, so we know E is the midpoint of AB, we know F is the midpoint of AC. Therefore, from that information, because of the midpoint theorem, we can conclude that EF is parallel to BC. And we also know that EF is half the distance or half the length of BC. But in this question in particular, the parallel lines is what I care about. So let's look at my triangle again. We know that T is the midpoint of PQ. We know that this new point over here is the midpoint of PR. That means that this line over here is parallel to QR. These are parallel lines. And did we not work out the gradient of QR earlier? Let's do it again. The gradient of QR is y2 minus y1. So 6, sorry, that's not y2. So it's 3 minus 2, y2 minus y1 over x2. So that is 6 minus x1, which is 9. We did this earlier. So that is 5 over negative 3. So therefore my gradient is negative 5 over 3. So if my gradient of QR is negative 5 over 3, we therefore know that the gradient of this new line, the one that they're asking for, is also negative 5 over 3. So how would you write this? Well, first of all, you would show me the gradient calculation as I've done here for QR. Then what you'll say to me is the gradient of this new line, okay, the gradient of T to the midpoint of PR. They don't really give this a name, which makes it a little bit difficult. The gradient of T to the midpoint of PR is equal to the gradient of QR. Why? Because of midpoint theorem. Because of midpoint theorem. And what information did they give us? We know that PT is equal to TQ. That's these two lines here. Those are equal. And then we also therefore know that P to the midpoint of PR, P to the midpoint of PR is equal to R to the midpoint of PR. It would be much easier if we had a name for this one over here. But basically, the information that we know is that this is the midpoint over here, so those two lines are equal. This is the midpoint over here, so those two lines are equal. Therefore, we can use midpoint theorem. That's our reason. Therefore, the gradient of the line through T and the midpoint of PR is equal to -5/3. That's using the midpoint theorem. If that makes you feel uncomfortable, I'm going to show you another way to do this. Right, so method 2, they want the gradient of this line. And we know that this, once again, is the midpoint of PR. Now, we know that gradients of a line is y2 minus y1 over x2 minus x1. So I know this coordinate already. I know t. We worked that out earlier. We worked that out in question 2.1.3. That was our answer. That is t. And we can find this coordinate over here. Once we have the two coordinates that's on the line, we can find the gradient of the line. Now, how do I find this coordinate over here? Well, we were told that it's the midpoint of PR. So I can find the midpoint of PR by using the midpoint formula. So if I say midpoint of PR, we know that we use x1 plus x2 divided by 2, y1 plus y2 divided by 2. So let's use the midpoint formula. Let's sub in. So remember, P is my one coordinate, R is my other coordinate. I'm going to use those two to find the midpoint. Just remember, it's x1 plus x2, so 1 plus 9. That comes from the x over there and the x over there. And then y1, which is 0, plus y2, which is -2. So plus minus, that's why it's a negative over there. And my midpoint, as I've worked it out, is 5 and -1. So now I know this coordinate over here, 5 and -1. Once I know both coordinates, I can use the gradient formula. So the gradient of this new line is y2 minus y1 over x2 minus x1. Now, it doesn't matter which one is your 1 and which one is your 2. I'm going to choose this one as my y2, this one as my y1. So y2, so 3 over 2, minus 1. So it's y2 minus y1. My y1 is a minus, so it's minus over x2, which is 7 over 2, minus 5. If you work that out, you get -5/3, which is what we got when we used the midpoint theorem as well. If you like this video and you want to see more like this, please give this one a thumbs up. Let me know in the comments below. I went quite slowly through this one just to help you understand the concepts. I can do a video where I go through a whole lot more in a video. Just let me know. Please subscribe if you haven't already, and I hope to see you in the next video. Goodbye, everyone.